Dear student, today we are going to show you how to build up a MATLAB Simulink for a first order or second order system with a date time. We will see now. Just let us share the screen with you, and then this is the screen we have. As you can see, this is first we open MATLAB, and then we open the Simulink from the MATLAB. These are the four squared in MATLAB. We'll get the library of the Simulink, and then from the file we open a new file, a new model, which is this is the new model. As you can see, this is the new model. To build up the Simulink, as you understand, and what we showed in the video, in the chapter 1, we have our process in Laplace. We have to choose the continuous where the process is. We have to choose the source, the input. We have to choose the output, the sink. Normally we choose scoop. We go back to the system. Let us choose the transfer function, drag it into the windows. We may enlarge it a little bit, and then we can choose there's a time delay. So here it is on the right hand side, the transport delay. We bring it in here by drag it. We can enlarge it a little bit, right? This is and then we can choose our source, which is the input. It could be sine, could be RAM. Let us choose the step. This is the step. We can enlarge it a little bit as a Windows. This is the transfer function, and this is the time delay. And for the sync, we choose the scoop, right? And then we could choose the workspace for data logging. So our data could be here. So any student can do whatever he wish with the recorded data. It means the response data. But here we will see but now for the process, we can play with the K value. This, as you can see, between the brackets, we choose maybe 2. This is the K, and the time constant. It is, you can see the transfer function as +1. First character is for the time constant. I may choose 5, so it is 5 as +1. When we can say apply, you can see the picture. It is 2 upon 5 as +1. Okay, it is done. For the step change, this is first one is the startup. Where to start, at 0 or after some time. We normally, in better patient, we choose 0. The size of the step change, which is the final value, we may say equal 1.5, the size of the step. Apply. This won't show in the step change because it is hidden. For the time delay, this is the time delay 1 minute, 1 second, depend on your time constant. Let us put it to 3. The date time, we don't play with the initial buffer. Apply. This is the answer. Okay. To make this diagram work, we have to connect the step change to the transfer function, and between arrows and transfer function to the delay. You can see the line between change color and shape from dot to the solid. It means a good connection. And then the workspace, it is connected to the process. Now the diagram is ready to run. To run that, we have to press the green arrow at the top, as you can see. And then if it is everything fine, we will hear a sound to show the response. This is the sound, means our connection, it is okay, nothing wrong with it. To see our graph, double click on the scoop. This is the picture that we have. Let us enlarge it a little bit. Right. Has gone down. This is the title. This is. That's the scope. Well, let us run it again. Large. This is the response. You can see this is the dead time or time delay. It is shown in here. I may change the transfer function to a second order system, either to first order or a second order system with s squared. Now this is to get it s squared. So this is it should be three terms. So it could be this is 5 as for the s squared, and then space we make it 2. So it is 5 s squared 2s plus 1 apply for the same gain. That's it is shown as you can see. It's okay. Now the same time delay, we can run it. This is run. So you can see now to see the picture of the response. You can see it is oscillation. It means zeta less than 1. It means zeta less than 1. We can play actually with the graph. We can change the color of the curve, the background, the color numbering, y-axis, x-axis, and so on. Just press in here, and then this is the give you the style and the history. This is the style for the color. For the general, this is automatic for the time scale, or that's what we put it in the top 40. We can play with that. And some new model of new version of MATLAB, you can play with the y-axis in here as well. With the style, we can change the color of the curve. You can see this is I make it red. Just apply. You can see the color become red. The color become red. This is even the size of the curve. It can be seen easily, and so on. For the x-axis scale, this is axis properties. For y, it is from -5. I can put it to from 0. Apply. Okay, you can see started now from 0. This is how building up a Simulink program with a time delay, as well as now we are building a process with a zeta less than 1 under damped response. I hope that it is okay, and thank you for listening.